So it's pretty much impossible to imagine modern life without the internet. It's this massive global network that connects billions of us, powering everything from how we work and learn to how we shop and entertain ourselves. It's the backbone of the digital age, a utility as fundamental as electricity for many. But have you ever stopped to think about where it all came from? It didn't just appear out of thin air. The story of its creation is actually a super interesting journey, filled with brilliant minds, Cold War paranoia, and a series of happy accidents that led to the connected world we have today. It's a tech origin story that's way more complex and fascinating than you might think. And that's what we're diving into today. We're going to break down 10 key moments and concepts from the very beginning of the internet's life. This isn't just a history lesson. It's about understanding the fundamental building blocks of the technology we use every single day. We'll look at the initial spark, the key players, and the critical decisions that shaped this revolutionary global network. From military projects to academic breakthroughs, each fact adds another layer to the story. So, get comfortable, because we're about to go back in time to explore the fascinating and sometimes surprising origins of the internet. We'll cover everything from the very first message ever sent, which didn't exactly go as planned, to the crucial decision that made the web accessible to everyone on the planet. Let's get into it. Alright, so first up, let's talk about where the initial idea came from. To really get it, you have to go all the way back to the late 1950s and 60s, right in the thick of the Cold War. The political climate was, to put it mildly, tense. The United States government, specifically the Department of Defense, was thinking about worst-case scenarios. A major concern was how to maintain communication and command and control after a potential nuclear attack. A centralized communication system was a huge vulnerability. Take out the central hub and the entire network goes down. So the Advanced Research Projects Agency, or ARPA, was tasked with solving this problem. They envisioned a decentralized, distributed network with no single point of failure. The idea was that if one part of the network was destroyed, information could still be routed through the remaining nodes. This military-driven need for a resilient, bomb-proof communication system was the seed that would eventually grow into the ARPANET, and by extension, the internet we know and use today. It's wild to think that the network we use for memes and cat videos was born from Cold War strategy. Now, having the idea for a decentralized network is one thing, but making it work is another beast entirely. The key technological breakthrough that made it all possible was something called packet switching. Before this, most networks used circuit switching. Think of an old-school telephone call. A dedicated, unbroken connection or circuit is established between 2 points for the entire duration of the call. This is inefficient for data because the line is tied up even when no information is being sent. It's also not very robust. If that connection is broken, the communication fails completely. A brilliant engineer at the RAND Corporation named Paul Baran came up with a revolutionary alternative. His idea was to break down large messages into small, uniformly sized chunks or packets. Each packet would be labeled with its destination address and sent out into the network independently. They could travel along different paths and even arrive out of order. The receiving computer would then reassemble these packets back into the original message. This method was incredibly efficient and incredibly resilient. If one path was congested or destroyed, packets could simply find another way. This was the magic ingredient that made the ARPANET's decentralized design a practical reality. So, with the theory of packet switching in place, it was time to actually build this thing. The project officially became the ARPANET, and it stands as the direct, tangible precursor to the modern internet. This wasn't just a theoretical model anymore. It was a real, physical network. The goal was to connect computers at different universities and research centers across the United States, allowing them to share resources and processing power. It was an incredibly ambitious project for its time, linking together completely different computer systems from different manufacturers. The historic moment came in late 1969. The very first node, which was basically a specialized router called an Interface Message Processor, or IMP, was installed at UCLA. Shortly after, a second node went live at the Stanford Research Institute. They were followed by nodes at UC Santa Barbara and the University of Utah, forming the initial 4-node network. This was it, the first large-scale, general-purpose computer network to use packet switching. It was the proof of concept that a decentralized network could actually work. laying the literal and figurative groundwork for everything that was to come. Every great journey has a first step, and for the internet, that first step was actually a bit of a stumble. On October 29, 1969, a team at UCLA led by Professor Leonard Kleinrock got ready to send the very first message over the ARPANET to the team at SRI. The plan was pretty simple. They were going to type the word login, and the team at SRI would see it appear on their screen. It was kind of like the digital equivalent of one small step for man. This was the moment of truth, the first real test of the network. Charlie Klein, who was a student programmer at UCLA, started typing. He typed the letter L, and over the phone, the team at SRI confirmed they had received it. So far, so good. Then he typed the letter O. Again, SRI confirmed receipt. He then typed the letter G, and the system crashed. The entire network just went down. So the very first message ever sent over this revolutionary new network wasn't login or hello or even some profound statement. It was simply lo, as in lo and behold. It's a perfectly humble and honestly kind of comical beginning for a technology that would go on to change the world. As the ARPANET grew, a new challenge emerged. It was its own self-contained network, but the vision was definitely bigger. People started imagining a future where different independent networks, like satellite networks or radio networks, could all connect and communicate with each other. They envisioned an internetwork, or what we now call the internet. But to make that happen, they needed a common language, a universal set of rules that all these different networks could use to talk to each other. This is where two absolute legends of computer science come into the picture, Vinton Cerf and Robert Kahn. Working together in the early 1970s, Cerf and Kahn began designing the fundamental architecture for this internetwork. Bob Kahn had worked on the ARPANET system architecture, so he really knew the challenges inside and out. Vint Cerf brought a fresh perspective, and together they tackled the problem head-on. They mapped out a new protocol that would be flexible enough to work across any type of network, regardless of the underlying hardware. Their collaborative work would become the bedrock of the modern internet, earning them the well-deserved title of the fathers of the internet. The solution that Cerf and Kahn developed was a two-part protocol suite known as TCPIP, which stands for Transmission Control Protocol and Internet Protocol. This is, honestly, the real core of how the internet functions, even today. Think of it as the universal language for all computers on the network. The Internet Protocol, or IP, is kind of like the postal system. It's responsible for addressing and routing the packets of data to make sure they get to the right destination computer. Each device gets a unique IP address, just like a house gets a street address. The Transmission Control Protocol, or TCP, works on top of that. Its job is to make sure the delivery is reliable. It takes a large chunk of data, breaks it down into those packets before sending, and on the receiving end, it reassembles them in the correct order and checks that no packets were lost or corrupted along the way. If a packet is missing, TCP requests it to be sent again. On January 1, 1983, the ARPANET officially switched over from its original protocol to TCP/IP. This date is often considered the true birth of the internet, since it was the moment a standardized universal protocol created a unified network of networks. You know, it's easy to think of the internet's history as a straight line leading to the websites and browsers we use today. But actually, one of its most important features predates the World Wide Web by, well, quite a long shot. I'm talking about email. Back in 1971, a computer engineer named Ray Tomlinson was working on the ARPANET. He created a program that allowed users to send text messages to other users on different computers connected to the network. This was a massive leap forward from just leaving messages for people on the same single computer. To make it work, he needed a way to specify both the user's name and the name of the host computer they were on. So, he looked down at his keyboard and chose a symbol that wasn't commonly used in names or programs, just to avoid confusion. He picked the @ symbol, ye meaning at. So a message would be for user at host computer. This simple, elegant solution, user at host, is the exact same format we still use for email addresses today. Email quickly became the ARPANET's killer app, accounting for the vast majority of its traffic and proving the network's value for human communication, not just remote computing. Okay, this is a really important distinction that a lot of people get wrong. The internet and the World Wide Web are not the same thing. It's a classic tech misconception. The internet is the underlying global network infrastructure, the hardware, the routers, the cables, and the TCPIP protocols that allow all the computers to connect and exchange information. It's kind of like the roads and the postal service. The World Wide Web, or just the web, is one of many applications that runs of the internet. It's the collection of websites and documents connected by hyperlinks. It's what you access with a web browser. The web was invented much later, in 1989, by a British computer scientist named Tim Berners-Lee while he was working at CERN, the European Organization for Nuclear Research. He envisioned a way for scientists to easily share papers and data across the internet using a system of hypertext. He developed 3 core technologies to make this happen: HTML, which is the language for creating web pages, URI or URL, which is the address for each page, and HTTP, the protocol for fetching pages. So, while email, file transfers, and gaming all use the internet, the web is specifically the universe of interconnected information that we navigate with browsers like Chrome, Safari, or Firefox. So Tim Berners-Lee had this brilliant idea for the World Wide Web. The next logical step was to, well, build it. And he did. Working on his next computer at CERN, he created the very first web browser and web server software. Then in 1991 he published the world's first website. It wasn't flashy. There were no graphics, no videos, no complex layouts. It was a simple text-based page with a white background and blue hyperlinks. The aesthetic was, let's say, minimalist. The site's purpose was purely informational. It was a website about the World Wide Web itself. It explained what the project was, how you could create your own web pages, and even provided instructions on how to search the web. The address was http://info.cern.ch. That page served as the entry point and manual for this nascent technology. While the original page is no longer live at that address, CERN has since restored a 1992 copy, so you can still visit a replica today and see for yourself what the dawn of the web looked like. It's a fascinating piece of digital archaeology. This might be the single most important decision in the entire history of the internet's growth. For its first few years, the World Wide Web was primarily an internal project at CERN, used by a small community of physicists. But for it to truly take off and become a global phenomenon, it had to be available to everyone, freely, and without restrictions. The potential was there, but it was locked behind licensing fees and proprietary technology, which would have massively stifled its growth. A huge turning point was needed. That turning point came on April 30th, 1993. CERN made the monumental decision to put the underlying software of the World Wide Web, the core code and the basic protocols, into the public domain. This meant anyone, anywhere could use, study, modify, and build upon the technology without having to pay royalties or ask for permission. It was an incredible act of technological philanthropy. This decision is what opened the floodgates. It allowed companies to build browsers like Mosaic and Netscape, which in turn made the web accessible to non-technical users, and triggered the explosive exponential growth of the internet throughout the 1990s and beyond. So there you have it. 10 fascinating facts that trace the journey from a Cold War military project to the global information network we rely on today. It's a story of foresight, collaboration, and a few key, game-changing moments. Understanding these origins, from packet switching and TCP/IP to that first failed login message, gives you a whole new appreciation for the complexity and brilliance behind the screen you're watching this on. The internet wasn't built by one person or for one purpose. It evolved through decades of work by countless individuals. The history of technology is constantly being written, and the principles of curiosity and problem-solving that built the internet are the same ones driving innovation today. So it's always worth digging a little deeper into the tools we use every day. Keep asking questions, stay informed, and stay curious about the world around you, both digital and physical. The story is far from over, and understanding the past is the best way to understand where we might be heading in the future. And on that note, that's it for this one. If you found this look back at the internet's history interesting, hit that like button and maybe share it with someone who might also find it cool. And of course, make sure you're subscribed to Top 10 Worldwide for more deep dives and insights into our world. We've got a lot more coming. Thanks for watching, and I'll see you in the next one.